Hi, everyone. Welcome to this session that we are about to start. So today we'll talk about satellite observations and also on water resource management in transboundary basins. So we are happy to welcome you today. So we will hear 5 different speakers. We will have Ezra Sutu from UNESCO Intergovernmental Hydrological Program. With so myself and Delphine Lou and Nicolas Gagné from CNES, the French Space Agency. We'll talk about how satellites can help monitoring water resources on Earth. We'll hear from Jean-Michel Martinez from the French National Research Institute for Sustainable Development about water quality over the Amazon Basin. And finally, we'll hear Blaise Dont from the International Office for Water about the use of satellite data in decision aid tools. So we wanted to welcome you and first ask you who you are. So please, you can write it down on the chat. We'll read them, all the comments on the chat. And if you have some time, you can actually answer the quick poll that we've set up for you on WooClap. You can either scan the QR code that you see on the screen, and also you can just copy what you see on the screen right now. So yeah, feel free to answer it. What kind of organization you're working for? So if you're a stakeholder, basin organizer, or politics, academics, whatever. So just write it down. We'll be happy to meet you. Also, during the presentation, feel free to write question on the chat. We'll see them. We'll answer them between the presentation or at the end if we have some time. So yes, feel free to communicate with us and exchange with us. All right. So Ezra, you can talk now, and then we'll talk to you later. Thank you.
Thank you so much, Delphine, for the introduction. And I want to welcome all our guest participants here. Thanks all for joining this session. I'm Esra Şıltu. I'm working as a water quality expert in UNESCO Intergovernmental Hydrological Program, Division of Water Sciences. And in this session, I will try to present our intergovernmental perspective on use of satellite-based data in water quality monitoring. Next slide, please. Next slide, please. Yes, thank you. Here you see the content of my speech. I will first try to remind you the Sustainable Development Goals and the relation to the water quality issues. And I will try to introduce the 9th phase of Intergovernmental Hydrological Program and the importance of water quality in its 9th phase. And I will introduce our international initiative on water quality and our World Water Quality Portal. And then I will sum up and my presentation with some few take-home messages. Next slide, please. So we can start with Sustainable Development Goals. I'm sure we all are very familiar with the concept of Sustainable Development Goals. You know, there are 17 Sustainable Development Goals adopted by all member states of the United Nations in 2015. And the Sustainable Development Goal 6 is aiming to ensure access to clean water and sanitation throughout the world. And there are several targets and indicators under SDG 6. And I also want to highlight that SDG 6 is now commonly accepted as at the heart of the all other SDGs. So we cannot achieve other SDGs without achieving SDG 6, without ensuring access to clean water and sanitation in all regions of the world. But the ones among these targets and indicators, the target 6.3 is directly addressing the improvement of water quality in all regions of the world by reducing the pollution. And there are several indicators to measure the progress of the SDGs of the SDG 6, but I think the indicators 6.3.2 and 6.5.2 are the ones which are directly related to our session today. because the indicator 6.3.2 is indicating the proportion of water bodies with good ambient water quality, and indicator 6.5.2 is showing the proportion of transboundary basin area with an operational arrangement for water cooperation, which necessitates the regular share of data and information between the riparian states. Next slide, please. And here I want to show some data and figures on the progress of these targets. In the screen, you see the progress, the latest data on the progress under the indicator 6.3.2. We see that the proportion of water bodies in the world with good ambient water quality is 56% currently, according to the data that we get from UNEP through the GEMS water. And the geographical coverage and the population coverage of the data seems acceptable. But this data also shows that around half of the water bodies of the world are not having the good ambient water quality. And I will show you some different figures in the next slide, which can indicate there may be some deficiencies in the monitoring systems in the other regions of the world. As you see in this figure, the data on the progress of SDG 6.3.2 is not uniform among different regions of the world. So some regions are not achieving good water quality, but some are having good water quality. So we need some uniform and standardized data in order to achieve SDGs, and we need to invest on monitoring systems to achieve these goals and to monitor SDGs effectively. Next slide, please. And here is another snapshot on SDG 6. In this figure, we can compare different indicators, the data on different indicators for sub-Saharan Africa. For example, here is the interesting thing is that I think the sanitation and wastewater indicators are around 20%. And the wastewater, untreated wastewater, is the main source of water quality, water pollution, But at the same time, we see that the water quality indicator shows that around 80% of the water bodies having good water quality. But this data only shows the water quality in the monitored water bodies. So that means that we are not able to monitor all water bodies which are under risks of population. So we need to enhance our monitoring system, and we need to improve water quality monitoring in all regions of the world. Next slide, please. Here I want to sum up these ideas. Yes, the figures showed us that we still have some lacking capacities, insufficient capacities to monitor water quality in some regions of the world. And as a result of this situation, we don't have a uniform, standardized, and comparable data on water quality. And we need this to monitor SDGs better, to implement the integrated water resources management approach, and to enhance the transboundary cooperation. Next slide, please. And in the 9th phase of Intergovernmental Hydrological Program, we have 5 priority areas to address these gaps and to achieve SDGs, to help achieving SDGs. I want to also mention that the Intergovernmental Hydrological Program of UNESCO is the only intergovernmental program within the UN system dedicated to water resources management and dealing with water issues solely. And the 9th phase has several expected outputs and key activities. We have one cross-cutting working group on eco-hydrology and water quality, and our priority areas are also aiming to address the data gap, to enhance scientific research and innovation, to promote implementation of integrated water resources management, and better water governance. Next slide, please. Next slide, please. Thank you so much. Among these outputs, the 8 are directly related to water quality, and we are working closely with our large water family and our member states to achieve the objectives of the 9th phase of the IHP and to support the achievement of sustainable development goals globally. Next slide, please. So in this scope, in 2012, UNESCO IHP launched the International Initiative on Water Quality as a flagship initiative to support the member states in protecting and sustainably managing the quality of freshwater resources. And since then, in scope of the International Initiative on Water Quality, numerous capacity development activities were conducted, like seminars, workshops, training, conferences, and lots of publications were produced and published. And we developed and launched the World Water Quality Portal as well. Next slide, please. The International Initiative on Water Quality is currently co-hosted by our members of our water family, UNESCO Chair on Sustainable Water Security in Florida International University, UNESCO Chair on Water, Energy and Disaster Management for Sustainable Development in Kyoto University, and International Center for Water Resources and Global Change in Koblenz in Germany. We thank our co-host. Next slide, please. And the World Water Quality Portal was developed and established with the support of our partners in 2015 within the context of this flagship initiative, and it was the first in its kind at that date. It's using the Sentinel-2 of European Space Agency and Landsat 8 and 9 satellites of USGS and NASA. Temperature, turbidity, suspended matters, chlorophyll A, including harmful algal blooms, and dissolved organic matter are the water quality parameters which can be measured through the water quality portal, and the data can be obtained through the portal. And also water surface area and water level data can be monitored through our Earth observation satellites. These data are really valuable to figure out the exact water quality and the ecological state of water resources, and on a lower cost compared to long-time in situ monitoring activities. Next slide, please. The demonstration phase of the World Water Quality Portal was conducted between 2015 and 2018 in 7 different regions of the world with the support of AOMAP. We thank them. And the operational applications were conducted in Lake Chad in Africa and La Plata Basin in Latin America. Next slide, please. Here I shared the links to our portal. If you are interested, you can go through these websites to check out what we are presenting there. Next slide, please. Yes, before ending my presentation, I want to give some take-home messages. I want to highlight some issues. We still need better and more comprehensive in terms of spatial and temporal resolution. We need more comprehensive monitoring of water quality to be able to monitor SDGs better, to reveal the actual status of water bodies globally, and to provide science-based solutions to current water challenges, and to enhance informed decision-making and policy-making procedure for better water governance, and to be able to implement the integrated water resources management approach, and to enhance transboundary cooperation. And satellite-based water quality and water resources monitoring observations can be really innovative and promising tools, and they can provide open data, open access data to address these issues, to address these needs. But to be able to disseminate the use of EO-based observations in water resources monitoring, we need more funds, we need capacity building, and we need more synergies between the member states, between the institutions, between the governance, and all members of the water family and all partners, stakeholders of the water society. And before ending my presentation, next slide, please. I want to highlight that the next year, 2025, will be the 50th year of the IHP and the 60th year of the water sciences in UNESCO. And we will have lots of celebrations throughout the year. We will have private events, dedicated publications, a dedicated website. The plannings are still continue. We will inform you about the latest updates. But if you want to be engaged in the celebrations, if you want to collaborate with us in our celebration, because IHP is your program, please feel free to reach out to us. Thank you so much for listening. And if you have any question, I can try to answer those. Thank you.
There's none in the chat for now, but feel free to ask them if there's any. And in any case, if you have further questions, maybe later, then you can still reach us with our emails that Ezra put here. We'll put them at the end as well. So just to answer Sarah, who's asking if we can get this PowerPoint, then I believe that this session is recorded, so you'll have all the information right after this session, or a few hours later, maybe. So don't worry, you can have this information again after that.
Thank you.
Okay. Thank you, Ezra. So with Nicola, we will move on to the next talk. So we're from CNES, which is the French Space Agency, and we wanted to show you what are the capabilities of satellites in order to be able to monitor the water resources on Earth. So first of all, a very quick overview of CNES. So as I said, the French Space Agency. We're collaborating with 44 different nations around the world. The budget, the annual budget is around 2.6 billion euros, and it includes the contribution to the European Space Agency, the ESA. We're working on more than 100 space projects around 5 key domains, which are the space transportation, science, defense, telecommunication, and also, of course, Earth observation. Regarding the the Earth observation program, so it's been built around 5 main pillars, which are sciences in order to better understand our planet Earth. Around technology, with a lot of innovation in our satellites, also around society in order to answer climate change challenges that we face every day. Around services, with the development and partnerships so that we can develop new services for populations, and also cooperation with different nations and other agencies. So if we list all the different hydrology components that satellites can help monitor, so we've seen 6 of them. The first one is the weather forecast. We have surface water elevation, surface water quality, agriculture, groundwater resources, and also cryosphere. So we'll go through all of them. So the first one, the weather forecast, and more specifically about precipitations. Actually, the operational services for weather forecast can rely heavily on satellite data, as they improve also in accuracy and also the number of days that we are able to forecast the weather. We also use these satellites for short-term discharge forecast. And here I'm talking mostly about the METOP satellites from EUMETSAT. And CNES has been working on the YASI instrument on board since 2006. And we're also working on the next generation of satellites with 3 of them, with the YASI new generation with EUMETSAT, CIEL with ISA, and also AOS with NASA and JAXA. So we have a plan for the next decade or so. Regarding surface water quality, so when we talk about quality here, we talk about color and temperature. So we are able to actually monitor temperature and also key biochemical indicators. So this is definitely an independent source of data that we can provide to all nations, all people. So right at the moment, we're working with Landsat, Sentinel, and also MODIS satellites, and we're working on Trishna with our Indian partners, the ISRO, which should be launched in a year and a half, so let's say 2026. And there will be a focus presentation presented by Jean-Michel, also about water quality just after us. So Nicola. No, we can hear you.
Okay, thank you, Delphine. I'm now going to present some of the contribution of satellite data related to water quantity monitoring. So satellite using spaceband radar can measure the elevation of both ocean and inland surface water. It began several decades ago with nadir altimetry. Nadir altimetry measures the elevation along a line below the satellite. It's useful to monitor both short-term and long-term evolution of large hydrosystem. In this example, we see the elevation of light shade basin since 1992. Next slide. More recently, the arrival of SWAS altimetry with CNES and NASA's SWOT satellite brought a new dimension to surface water quantity monitoring. SWAS altimetry provides a two-dimensional map of water surface elevation, not only just a line under the satellite. This enables the monitoring of much smaller water bodies, starting at 1 hectare, and even the estimation of water discharge through waterways. Next slide. In this example, the graph shows elevation of water along a small artificial waterway. Each image corresponds to a specific date. This waterway lies within the Nile River basins. The discontinuity in the graph shows correspond to the dams. So we can see day to day how this irrigation infrastructure is operated. On the right side, the slope of the water can be used to estimate the water discharge through the canal. So how much water is used by the downstream fields. Currently, CNES is working on new satellite with improved revisit time, Sentinel-3 new generation, and also high revisit hydrology constellation. Next slide, please. One other component is agriculture, which accounts for a significant proportion of water withdrawal, and this must be taken into account in the large-scale management of transboundary basins. Here are some examples of information that satellite can provide. First is crop mapping, as we know that some crops require more water than others. Here we see a strong concentration of cornfields in yellow on both sides of the transboundary Rhine River between France and Germany. One other, next please. Okay, thank you. One other is soil moisture estimation, which estimate how much water is available to crop roots at a given time using a radiometer and radar satellite. This gives an indication of near real-time irrigation requirement at quite large scale. Next slide. By combining, this was for the irrigation needs, and by combining multiple sources of data, we can estimate how much water has been used for irrigation over a period of time. In this example, we see an example in the Po River basin between Italy and Switzerland. Currently, scientists are working on using the thermal imagery satellite, like Landsat or the future Trishna mission, to map the evaporation and water stress of crops at the scale of a specific field. Okay, next slide, please. Oh, okay, thank you. As for groundwater, of course, satellite cannot directly see groundwater, but we can use it to monitor the large-scale evolution of large aquifer through the impact of the aquifer on the Earth's gravity fields. This is done using gravimetry, like with Grace or Grace Follow-on, and later projects like MAGIC and Carioca. In the example, we see the groundwater depletion in the California Central Valley that has been caused by overdrought for irrigation. Next slide. Okay, so the last component we wanted to mention is the cryosphere. We know that some basins are fed in summer by the melting snow and glacier, which can be located in another country. For example, in Europe, as a part of the water used by the downstream population in the Rhine, Rhone, and Po Valley come from the melting cryosphere in the mountain in Switzerland. Next slide. So satellite data is already being used by policymakers for short-term water management. For example, it gave early warning on low summer runoff. In this example, as soon as early March 2022, we saw that snow extent was very low compared to previous years. The summer shows worst drought in recorded history in this basin. As for longer time management, satellites are widely used by scientists to assess the impact of climate change on mountain cryosphere. They use it to build a projection for various scenarios. And then their work is used by policymakers and stakeholders of both upstream and downstream countries to build adaptation strategy. It can be adapted policy, regulation, or infrastructure like water storage in upstream country for us in summer in downstream countries. So thank you for your attention. I will be happy to answer your question in the chat or later by mail. Thank you.
Okay, so one of the questions was actually how to access data. So we had a slide actually for that. So at CNES, we have an integrated approach, meaning that you can access all the data that are that have been actually acquired from satellites through DataTerra that we've built with our partners. And the one that has been created for hydrology is called hydrorep.next. It's a multi-source, multi-sensor data for use at different spectral and temporal scales. You can actually access them totally for free, and it's for any type of users. You can be a scientist, stakeholder, or just a curious person who wanted to have a look at what's going on. You can actually access those data. And I've put the website also on the right side. And here I show two illustrations of this hydrorep next, so that you can see in the form of a map, so you can actually see what's going on. And also, if you're interested in only a lake or a river, you can actually see the time series from I think the oldest data that we have is from 1992. So you can clearly see the time series of the water elevation of the lake, for example. So finally, if we go back to this list, you have seen that satellites can actually look at precipitation, atmospheric composition, storage changes for lakes and reservoir, discharge, also some key parameters for water quality, and also soil moisture, evapotranspiration, water stress, and land cover map for agriculture, total water storage at large scale for groundwater resources, and also snow and ice quantities in mountainous areas. So the take-home messages for you. Satellite observations are an essential addition to field measurements that are made by local actors that could be non-uniform with a limited availability, as Ezra mentioned. All those data are free accessible, at least the ones from CNES, ESA, Copernicus, and other national agencies. At CNES, we have a unique expertise in water resource observations from space with a great ambition with future satellites for the next decade and also further, also with international collaborations. Also, we totally support the local stakeholders who would like to implement the use of satellite data in their activities. So feel free to contact us. We'll be happy to help and show you how to access those data and maybe have a project together to help you. So thank you very much for this section. That will be all for CNES.
Delphine, I think you have one last question. What is the precision level of the groundwater estimates?
Yeah, I'm not sure how to answer this question because I don't have the numbers right now at hand, but I will look for it and I'll come back to you, Alejandro, later because I don't have the exact number. Maybe Nicola, you have it. The precision level of the groundwater.
Not sure. I guess it's a few millimeters. What is measured is
no, the groundwater estimates.
Yes, it's the equivalent groundwater change in terms of equivalent millimeter of water, which is a mass of water over an area, and it's a few millimeter equivalent water, but it's actually groundwater.
Okay. But we'll come back to you with the real numbers. Sorry about that. We don't know everything. Okay, so next topic is Jean-Michel.
So, hello everybody. You're listening me? Yeah. Okay. So I'm Jean-Michel Martinez. I'm from a French Research Institute, IRD, which is working in South America and in Africa and Asia, especially about water resources. And we work a lot with CNES and UNESCO, for example. So I want to share our experience about water. So, yep. Next one, Delphine. Can you change the slide?
Yeah, I'm changing, but maybe you don't receive it. So
here it's okay.
The context, right?
So I go on. So
okay.
Yeah. Thanks. So the Amazon basin is shared by 8 different countries, and you have you meet different conditions in terms of resource funding. So the previous Delphine, the first one, and I was saying that we have different countries with really different and contrasted conditions about water management infrastructure fundings, which makes really difference in the way they can monitor the water resource in the different countries, from Peru to Brazil to Suriname or Colombia, for example. So we have a lot of issues, of course, in the Amazon about climate change, with really extreme floods and increasing dry periods. We have this year, for example, a new dry period, which is coming, dramatic one. And we have a lot of regional issues as well, as you may know, about deforestation and exploration, for example, for gold mining, but has a lot of implication about water quantity and water quality. Next one, Delphine. So the issues we have in this kind of catchment, I think it's really generic of what you can meet in different over region in the world. We lack a sufficient field network of station for monitoring. We have one map here I got from the OTCA organization. In fact, you can see about 150 or 200 stations, but we could put here the whole Europe map, for example, on this map, to have an idea about the size of the catchment and the low number of stations we have. More issues about the fact that most of these stations present short time series, which is really an issue about when we try to assess the impact of climate change, a longer time scale. About water quality, one of the issues is the fact that protocols are different from one country to another, which makes it difficult to compare the data. And we have also problems about data sharing. For example, last year we have a huge drought period at the end of 2023, and some countries shared the data with a 3-month delay, just to give you an idea about the issue of data sharing and data availability between the different countries for water management. So next slide. So at IRD, we developed for more than 10 years cooperation with national and regional stakeholders. I would like to mention especially here the cooperation we have with the Brazilian Water Agency, ANA, about the use of satellite data for water monitoring, water cycle monitoring, either for water quantity and quality. And we have also a new cooperation with the Amazon Corporation Treaty Organization, ACTO, also with OEO organization. A strong important point is for this project to bring the remote sensing data, satellite data to the stakeholders. It was important to make a lot of validation. So we have developed a specific network for data acquisition on the field to use and to validate the satellite data and to show these results to the stakeholders. So I can't here go in much detail. I wanted just to explain that we developed different softwares that were delivered for the stakeholder. We made a lot of capacity building, and we finally developed a web server on their own to deliver this data to the community, other stakeholders, and private sector as well. Next slide, just to give an idea about what I'm talking about in terms of variables. Delphine? Yeah, thanks. So here I wanted to talk more specifically about water quality. We use different sensors. We use sensor from NASA. We use sensor from the European Space Agency. For example, here an example about the use of what we call low resolution sensor, but that can provide long time series. So what you get on the left here is the suspended particulate matter sediment fluxes measured in the field on the Amazon River. It's the database of the Brazilian Water Agency on the left. You got about 30 data in almost 30 years. And you can get on the right what we can get from satellite for 20 years using MODIS data, for example. So on the left, you have 30 data. On the right, you get more than 1,000 data for the same variable for the Amazon River at the Amazon River surface. So this amount of information is really important when we try to use monitoring to help to make a better assessment of water resources. And for example, sediment fluxes can be interesting when we try to assess gold mining impacts in the Amazon basin. Next one, please. Now we are working also on a high resolution sensor. We try to produce maps for the stakeholders. So the next one, please. And we use new sensors such as Sentinels from the European Space Agency. So these works are made also with CNES. So it's the obstacle processing chain that is also available on the HydroWeb Next interface. And here is an example. You get the satellite image on the right part, and then you get a map, the water quality map for suspended particulate matter concentration. So you can get a huge amount of details that would be impossible to assess using field measurement, especially in this region. Next one. So we developed with the Brazilian Water Agency a database which is available online, where you can get either altimetric and water quality information. This database is run by the stakeholder, Brazilian Water Agency. I think it's an important point because we wanted them to really to own the data and to use this data be root in their. So it was important for them not just to download data, but also to be able to produce the data in the different catchments. So we're starting on the Amazon. In fact, we extended it on different other regions in Brazil, for example, with ANA. Next one, and this experience helped us to try to work on over catchment, transboundary catchment, for example, such as the experience we had with UNESCO on Lake Chad, so such as Isra was talking about. All what we've done with ANA in Brazil and on the Amazon was useful to develop the World Water Quality Portal on UNESCO portal on Lake Chad. And again, we tried and we bring the data to the local partners, and we made some training, for example, locally to explain how these data are produced, what is the accuracy, how they can use this data for data monitoring, of course, but also for management of the catchment. So to finish, just some take-home message. What is interesting, I think, for transboundary basin is that remote sensing can provide a great amount of data. Delphine, the last one, please. And so it's really a huge amount of information for the stakeholders. But this information and this amount of information can also be a problem for local stakeholders. So it's important to have capacity building programs and training. We are working for more than 10 years, for example, with the Brazilian Water Agency. We made a lot of capacity. We have also academic program with them to make sure that people understand what satellite can measure, what we cannot measure, and how they can use this data in the management plan, for example. So this is basically the information, and the last image here is coming from a situation room from the ACTO, where they gather both field measurements and satellite measurements for water quality and for water quantity. Thanks.
Thank you, Jean-Michel. So I think we've answered the question in the chat directly, and we can move on to the last talk from Blaise.
Yes, thank you, Delphine, for giving me the floor, and good morning to everyone who is listening to us today. So my name is Blaise Dante. I work at the International Office for Water as a project manager, and today I'll try to present some example of space altimetry applications for water resources management. Next. So for those who don't know our organization, the International Office for Water is a French non-profit association that has been developing skills for improved water management in France, Europe, and worldwide for about 30 years now. And we operate in 80 countries with more than 150 partner organizations. And we have 4 main fields of activity: educational engineering, development of stakeholder networks, international cooperation, and data management. And it is mainly in these 2 last fields that we develop pilot projects for Earth observation for IWRM. Next, please. The International Office for Water is also the permanent technical secretariat of the International Network of Basin Organization that brings together 200 members from 90 countries, including basin organizations, governmental administration, and different types of cooperation agencies. And the goal of this network is to promote integrated water resources management at basin scale, including at transboundary level, and it includes the use of space hydrology for IWRM. Next, please. So as a short introduction, I will just recall that improved monitoring of water resources is essential for better management, especially in the context of climate change, increasing anthropogenic pressures on the resources, and as said by my colleagues, the often declining in situ monitoring networks in transboundary basins. And we believe that satellite observations offer a unique and a well-suited solution for transboundary context because of the global and holistic perspective that transcends borders and that is now capable of tracking the entire water cycle, which is what it was shown in the CNES presentation. And well, in this context, for 10 years now, the International Office for Water has been promoting the use of space hydrology as a complement and in combination of field monitoring to support IWRM in transboundary basin. And next, please. So this is a view of the SWOT satellite that was already introduced, and the Mbata gauging station in Central Africa in the Congo River Basin. And it illustrates how data travels through the different levels of stakeholder, from the space agencies to organization involved in applied research, to regional and transboundary organizations such as the SICOS, who is the International Commission in charge of the Congo River Basin, to national authorities, down to the very most local level that is embodied here by the person who is in charge of reading the scale every day at the Mbata station. And these different scales are linked together and depend on each other. For instance, the data that are collected manually every day are useful for satellite data calibration and validation. And in return, satellite data can be used to help operating and complementing the information that is produced by the field monitoring networks. The graph on the bottom side, right side, shows the comparison between satellite data and field data. So we can see that there is good consistency here at the Mbata station. Is from the work by Kitambo, 2022. And last but not least, I would like to point out the fact that all this work we're doing with satellite and data about water resources should be for the benefit of local communities and to improve their daily lives and their resilience. And therefore, it's important to in this program to try to develop operational applications that are useful on the ground. Next slide, please. So the different example I will show are the result of different collaboration between French partners in an effort to try to align scientific and technical approaches in space hydrology with end user needs, and to develop a value chain between space and resource stakeholders, operational service providers, that can be private companies, and transboundary basins organizations. So we worked a lot with CNES, with the French Institute for Research and Development, and the French National Research Institute on agriculture, with the financial support of the French Development Agency. And the main project that is now going is the DYNOVA project, and we have activities related to space hydrology in 6 transboundary basins in Africa that you can see on the map. We have also other case studies in Brazil, French Guiana, and so on, but I won't present them today. Next slide, please. So one of the oldest case study we have is in the Congo River Basin. So one thing that is very interesting when working with satellites is that you actually can go back in time, depending on the satellite you're working with, sometimes for several decades. And therefore, in the Congo River Basin, a hydrological database based on space altimetry was reconstructed. And satellite data and field data were both integrated into the same hydrological information system run by the SICO, so the International Commission for the Congo River. And well, this actually new knowledge that was generated helped us better understanding the functioning of a poorly gauged basin, such as the Congo River one. Next slide, please. So two examples of very specific applications for water use that were developed, let's say at demonstration level. The first one, was a mapping of the potential for micro hydropower in the basin. So this is the map you can see on the right with the reaches that appear in red, being the reaches with the highest potential. So this computation was made based on discharge and slope measurements from satellites. And the second application was to improve river navigation. It was directly based on altimetric measurements from satellites. And these results were disseminated in a regional forum held in Cameroon on water resources management and space hydrology. So now it's been almost 5 years, but this is an example also of outreach activities that we've been conducting. Next, please. So now we can move to the Niger River Basin. That is another large basin in Western Africa. To illustrate how the teams of the French Institute for Research and Development implemented the MGB model. So the MGB model, MGB actually stands for Model Grade Basin. It was first developed for the Brazilian context and then implemented also in Africa. And it uses real-time satellite rainfall products and assimilate altimetric data from satellites and to provide hydrological forecasts. And this is a very useful information, for instance, for the Niger Basin Authority for flood forecasting. You can see on the graph on the bottom right how the annual flood that is measured at Niamey is well reproduced. Next slide, please. So now if we actually, cross the Atlantic Ocean and move to French Guiana, this is an example of how the outputs of the MGB model I was showing before can provide the background information for an online tool actually dedicated for flood alerts that can serve as a base for an early warning system strategy, for instance. So in this case, it was co-designed with the national authorities to be sure to meet the civil society needs. And it sends daily alerts by email, depending on the water elevation and the thresholds that are measured by different satellites equipped with altimeters. And you can see this interface is quite simple and user-friendly with a simple color code. And I think it's a very good example developed by the startup Little Matters of operational tools. And we're actually planning to develop a similar tool in the African basin I was showing before. Next slide, please. So this is my last example. It's in the Senegal River Basin. So we move back to Africa again. And it's to illustrate a bit how the satellite data that are actually provided by CNES in the hydroweb.next portal that was presented by Delphine are automatically integrated in an online platform along with field data from national and regional database. So this portal is actually run by the OMVS, which is the international, the transboundary organization in charge of the Senegal River. And it provides them with a very simple visualization dashboard that facilitates the access to this kind of data and can be used also to do some data consistency check. So it's a portal that is still under development, but it's a good example of what can be achieved for a transboundary basin organization to better use satellite data. Next slide, please. So now a few messages as a conclusion. So we believe that satellite data can enhance access to water-related information and data sharing, which is crucial for effective transboundary water resource management. And I can even say that we believe that satellite data can be a very good vector for transboundary cooperation. There's numerous benefits for water resource managers to use satellite data. It includes global basin coverage that ignores borders, access to remote and difficult to reach areas, cost reduction in data production. Most of these projects are available for free. There's no maintenance cost. Also, the operational satellite missions we're working with have long-term observation guarantees, for instance, with the European Copernicus programs. And the data consistency, free access, and transparency provided contributes to trust building, which is actually very important when talking about transboundary cooperation. I think there's still effort to better integrate satellite data into data production, data management, and database decision making. Since satellite data is still underutilized by water managers, we think that it is still important to continue to raise awareness, provide trainings, and develop pilot projects that includes end-user feedback and capacity building activities for effective implementation. Next slide, please. So this is my last slide. I just wanted to mention this new initiative supported by the International Network of Basin Organization and the World Meteorological Organization, which created during the last World Water Forum held in Bali, Indonesia, a task force on satellite operating techniques and new data integration technologies supporting water resource management that will aim at supporting the sharing of knowledge on these topics that we talked today, and to demonstrate what can be achieved on the field in 3 pilot basins that still have to be identified. So it's a really new initiative, but please don't hesitate to get in touch if you're interested. Thank you for your attention, and I hope you enjoyed the presentation. Thank you, Delphine. I'm done.
Thank you, Blaise. And thank you all for actually interacting with us while we were talking. And just as Blaise said, we hope you enjoyed the presentation. So we just want to keep you 2 minutes if you still have some time. One last question. Do you use Earth observation data? And if yes, what kind of data are you using? We would be very interested to know what you're actually using to do your work, your daily work. And if you have even more time to spend with us, we've built a little survey, so for yes/no questions, so very quick. So if you have some time, just come and visit us and answer some of those questions for us, so we can learn from you what are your needs, what you are, and everything. But again, thank you very much for attending this session. Thank you very much for your interesting questions in the chat. I believe we've answered, if not most of them, I think all of them in the chat, but feel free to reach us at those emails that we've put at the end of the presentation. We've been very happy to present you this side of how can we manage water resources with satellite data. So please feel free to reach us with our emails. And thank you again for your participation, and we hope you enjoyed this session.